We want to look at our fluid compartments, what is in the fluid compartments, and how things are going to be transferred from compartment to compartment. Okay, we're going to start with this big box here, and we're going to divide it into 1/3 and 2/3. Okay, the reason that this side over here is much larger is because it's inside of the cell, and 2/3 of the fluid in the body is inside of the cell. The fluid that's inside of the cell is in the intracellular space, and this is called intracellular fluid. Outside of the cell, you have the extracellular fluid, and the extracellular space is going to be divided into two parts. You have the plasma and the interstitial space. And the interstitial space has interstitial fluid. Okay, let's look and see what the fluid is made up of. Okay, we have solutes and solvent. Okay, we probably have heard of both of these words in chemistry or somewhere before. The solvent, the universal solvent, is water. So, what medium is in our bodies for your solutes to be dissolved in? Water. That's the reason for that. Okay, so solutes are dissolved in solvents. Okay, and like I said, the universal solvent is water, and that's the one we're going to be looking at in our body. So solutes are divided into molecules called electrolytes and non-electrolytes. Okay, electrolytes are charged particles, and we typically think of them as ions, and in chemistry a lot of times they're referred to as salts. Anything that you're going to say something ion is going to be an electrolyte. The most common ones, and we've used these all semester, is sodium, potassium, calcium, magnesium. Chloride would be a negative. Okay, hydrogen ion, any of those things that are going to have a plus or minus sign after them are going to be charged particles, and we refer to those as electrolytes. Non-electrolytes are also going to be in the fluids, and they are going to include glucose, hormones, carbon dioxide, oxygen, urea. Notice anything that we're spelling out and we don't have a plus or minus sign with, and we don't say the word ion after it. Okay, we want to look at how molecules are going to move between the compartments. So we have the plasma. Molecules have to move from the plasma into the interstitial space. If they're going to go into the intracellular fluid. So molecules would only be able to go from, let's do a different color here. Stupid. Okay, from the plasma to the interstitial space, molecules can go this direction. And we've studied this before. And you remember hydrostatic pressure. So that's what we're going to be looking at. Molecules go back into the plasma from the interstitial space by osmotic pressure, and that's osmotic pressure. We've looked at that before on how a capillary works, and this is exactly what we're talking about here. So let's draw our capillary. Our capillary will have an arterial end, and it has a venual end. Blood is going to go this direction, right? Okay, plasma is the water portion of the blood, so that's what we're referring to as the plasma. You have a high hydrostatic pressure on the arterial end, and you have a lower hydrostatic pressure on the venual end. If you want to put numbers here, hydrostatic pressure would be about 40 on the arterial end, and hydrostatic pressure would be about 20 on the venual end. Okay, this is going to cause fluid, water, electrolytes, and non-electrolytes to be pushed out of the capillary. So what is going to go into this interstitial space? You're going to have water, you have electrolytes, and non-electrolytes. Typically, this is going to be called protein-free plasma. If you remember the components of plasma, you had plasma proteins, water, and the dissolved substances. And the whole list of dissolved substances included all of these electrolytes and these non-electrolytes that we've written over here. Okay, so let me erase just a couple of things here on the sheet so that we'll have more room. Okay, so that's our hydrostatic pressure. Let's look at the pressure that's going to push the fluid back into the capillary. Fluid is going to go back into the capillary because the capillary is more concentrated on the venule end than it is on the arterial end. So you're going to have an osmotic pressure. It's called the pressure from osmosis, and that's going to be about 25 here on the venule end. So a little bit of fluid is going to go back in. Over here on the arterial end, you're not going to have much of an osmotic pressure. So the osmotic pressure is very low down here on the arterial end. So it's going to be something like, let's say 10. Okay, whenever you compare this, the hydrostatic pressure being 40 compared to an osmotic pressure of 10, you can see that there's a lot more fluid coming out. There's a lot more fluid coming out going into the interstitial space than what is going into the plasma. So you're going to have a net movement of water. So there's going to be water left over, water in the interstitial space. And this is going to be carried away by your lymph capillaries. And we studied your lymph capillaries, your lymph vessels, your lymph veins, your lymph nodes, and how all of that goes back into your subclavian veins when we looked at our lymph system. Okay, so now let's look at the molecules that are going to be, or how molecules go from your interstitial space into the intracellular space. Okay. We want to look at how molecules go from the interstitial space to the intracellular space. Okay, can you tell me what separates the interstitial space from the intracellular space? This structure right here, I don't know where it went to. Like it was erased. I don't know where it went to. But this structure right here, separating the interstitial space from the intracellular fluid, is the plasma membrane. And some people call that the cell membrane. Same thing. Okay. In AMP1, in biology, you probably have heard before that the cell membrane controls the substances moving in or out of the cell. So here we're going to have, it's basically, I'm going to list it out. In between your interstitial fluid and going back and forth to the intracellular fluid. Okay, the way molecules are going to move between the interstitial fluid and intracellular fluid are divided by what molecules they are. You remember water? Water's the universal solute, and it's going to move by osmosis. Okay, the interstitial fluid and the intracellular fluid are always going to be equal in concentrations. If you remember the word isotonic, the water is going to move by osmosis, making isotonic environments, making the environment between your plasma and the interstitial fluid and the intracellular fluid isotonic. Okay, ions, remember those are those charged particles or electrolytes. The electrolytes are going to be moving, they're going to have different concentrations inside of the cell and outside of the cell. Okay, they're going to differ in concentration because of their charge. Positives are going to be attracted to negatives. So the electrolytes are going to differ because of their charges. The most common example of that is the sodium-potassium pump. If you remember that the ions will also be moving because of active transport. Non-electrolytes, these are going to move. I'm running out of time here. I spelled it wrong. The non-electrolytes are going to move by diffusion. And what does diffusion do?